Hi, welcome back. So today we're going to talk about adverse event Adam dataset. Okay, let me open the file here. So I have here ADAE. Okay, so I already written the code part here. Let me go check the specification first. So here in the specification, we'll be having this is occurrence data structure. Okay, this adverse event analysis dataset will be the occurrence data structures, and it will be having the all the predecessor along with the derived ones. So predecessors, so when I remove this part, I'll be having only few variables to derive, okay, as per the specification. And there are some variables which are assigned, okay, and there are some variables which are coming from the supplementary AE. Okay, let me check if I, for example, here is most of them are TRT, EDT, TRT, so it will be okay. It will be similar. TRT01P will be having the TRT ADSL part. ADSL we are getting all the related age, and I don't see any difference here up to, and even AE as well. In AE we also having up to here will be the similar variable names. For example, here for AD, AE, SOC, CD, right? So in AE also we'll be having the same thing. So if we have a different variables here, so we have to map it, we have to assign. So no, I don't see any difference. So what I can do, I just make them as a completed for now, because I can directly import from ADSL and ADAE. So I'll make it to green color. Okay, next what I'm doing here, so now we will be having, so this one AE and DTC also we are okay, because it is directly predecessor from the AE dataset. Okay, so even AE SCR will be the same thing. So I'll keep it this one, this part. Then next, the predecessors are here: AE action OTH, here also AE action OTH, and AE action AA action. So this one I need to change it. I need to assign this part. This one is okay, you can directly get from this one. AA action I have to keep it as a different. Then AE out, AES Kong, AE disable, AES GTH. So is all of them are coming from the AE dataset, SDTM AE dataset. So this one also I keep it as a green color. Okay, so now what I can do, I just filter out by color. So I filter by color here, so I'm taking only the white part. Okay, so here most of them are derived, and there is one predecessor, so this is also we completed. So maybe I can keep it as a green. Let me check the other ones. AE and DY also is coming from AE dataset, so which is also I'm putting green color. And if I see any other thing, so and the action we have to do it, because here the variable name is different and here is the variable name is different. Okay, so I'll filter out again. Maybe I let me filter out again color. So I clear with filtered, take the only the white part. Okay, let's continue with the programming now. So here in the programming, I'm resetting that the previous any output variables I am output, we can be reset them. Then I'm stopping the logs if there is any previously logging on the file, so I'm stopping that one. Then I start the new freshly new with the ADAE. Okay, so let me run this part. Okay, so now the activating the auto logging. So here it is going to ADAE, it will be the there. So it is going to log it here, ADAE log. Okay, then what I'm doing here, I'm importing all the necessary packages: pandas, numpy, pirate state, data team, and pathlib from the and also I'm also assigning the path, Adam path and SDTM path and raw path. Okay, for importing that SDTM and Adam datasets. So what I'm doing here, I'm doing the class and object here, because for SDTM, because the SAS7B dat it cannot be read inside the Python, so we have to import in the SAS7B dat by using this format. Then I import SDTM dataset by using the get function here to get AE. Then I'm dropping the arm and actual arm, so we don't know this ones, and errors should be the ignore. Then I'm sorting based on the unit subject ID A sequence, and I'm resetting the sequence values, sequence for the records. Okay, so I'm resetting it. Then what I'm doing, I'm just taking the SDTM supplementary data set, supplementary, I'm getting the supplementary Then I'm assigning the AE sequence by PD numeric for the ID var and error should be the course, so there should be no errors. And then I am sorting the value by using the unit subject and the AE sequence. So what I next I'm doing by pivot table, so which means I'm transposing them by using the unique subject ID and AE sequence, and I'm taking the qnum and qval as a value for those ones and resetting the index. Okay. Okay, so now I'm gonna check with the supplementary trans. So when I check the supplementary trans, you can understand here. So all these ones are coming as a columns, and these values, the QL values, are coming in the as a row. So there should be 26 rows and 6 columns. Okay. Okay, so we'll check the specification if there is any supplementary AE has required. Okay, I don't see anywhere in the supplementary AE is there. For now, we're gonna continue here. So next, what I'm doing, I need to import the Adam datasets. Since Adam dataset also in the SAS7 BDAT, so we need to import by using this function Adam dataset macro. So Adam dataset is here. I'm just using the get function to get the ADSL. Then what I'm doing, I'm merging with AE1 with this. First I'm merging with the AE supplementary SDTM AE with supplementary trans, which I transpose them by using the unit subject and AE sequence, by using how I'm doing a left join. Then what is when I come this is creating the AE2 as a new data set, and AE2 along with ADSL I'm combining with the merge statement and using the on by using the use subject ID that by in inner join. So you understand the pattern how it pattern. First we import the SDTM AE, then we import the supplementary AE, and supplementary AE we cannot convert as a proc transpose. Then we import the ADSL, then I combine the supplementary AE with this SDTM AE. Then I combine with the whatever the data set is coming from the supplementary and this SDTM AE, I combine with ADSL by using unique subject. It is the common variable in inner join. Okay, next I'm doing with the severity function. So let's check the AE severity here. If we check AE severity, so here what is they saying? So AE severity mild equal to 1, moderate equal to 2, severity equal to 3, life threatening equal to 4. So they are is giving the numbers 3, 1 and 4. So what I'm doing, I'm giving the format values here in the dictionary format okay. So I'm giving the values here. So if it is a mild, I'm giving as a 1 as a mild, moderate in the prop case, because let me check this AE3 first. AE3, when I open the AE3 here, so I have to go to the AE severity. So if I go here, AE severity, so I put here. So if I check the AE severity here, now I see all of them are uppercase. So there are three distinct value: mild, moderate, severe. So it's asking another one is life threatening. So we don't see the life threatenings there, so, but we're considering them because as per the specification is asking, right? In the specification is asking life threatening as well. So for that reason we have to consider. So there is only three distinct values. So in the three distinct values, I'm giving as a prop case 1 and the 2 and the 3. So all of them I'm giving as a prop case. If AE3 has AE7 and AE, okay, let me go here. So what is this value? Is analysis severity. Okay, and so here we are creating the analysis severity numeric format, analysis severity character format. So if AEC apply the lambda functions severity map, so this is the map get x. So in numpy is no missing if it is giving this one, and the remaining is are missing for the both variables, and applied in the panda series. Okay, so what does it do if it is mild and it giving the numeric format as 1, and if it is a string format character format it's giving as AECV. So this is the way it works. So it gives two values at the same time. So when I check the AE3 here, if I refresh it, so I go on the top back. So now you can able to see the mild has given 1 and the severe has given 3. So I can able to do like most of them 71 one has a, because mild has a 17 counts, and severity and moderate has a 7 counts, and the severity has will be having the 2 counts. Okay, so that is good. We have derived these two, see, in the numeric format as well as character format. So I'll keep this one as these two. Next, what I'm doing here, so the next I'm doing here, okay, so next I'm doing that relative ARL variables. If I check the ARL variables, if I go here, so I'll be having the analysis causality. So there are two occurrence, two variables. So what is this asking? If I expand this part a bit, if it is definitely related, then in the prop case as a definitely related, and if it is probably related, then we have to give as probably related, not related. So we have to assign because this is assigned variable, so we have to assign. And if we take numeric format, we have to give, if we definitely related, we have to give 1, 2 and 3, and like that, so on. Okay, so continue with this one. So let me so here also will be the similar pattern. For example, if I go check here, and if I click on that one, a r e r e l. Okay, so here we'll be having a 3 distinct value: unlikely related, possibly related, not related. So you can be copied from here and paste it there, and you can give as a definitive prop case, and the one should be given to that ARLN. So how we doing here? So here we have using the lambda functions to get real map get, and applying for the x position here, and if there is nothing, then we give as the missing values, and in the PD series, then rel group 1. So the rel group 1 will be, what is that rel group 1? So pooled causality group. So if ARL in 1 or 2 or 3, then set to related, else set to not related. Okay, so if ARL apply related if x in 1, 2, 3, else not related. So this is the way we have to assign. So if I go here and refresh the data, okay, if I go ARL here on the top, so here you will be see the rel group here, related, not related, 1, 2, 3. So here the total 9 counts has possibly related, and 11 counts will be having the unlikely related, and 5 counts will be the not related. Okay, so here once we done that, then we go to the action variable here. So these 3 are done. Now we'll be having the action variable. So AE action in prop case, so this is in the predecessor. So AE actions in the prop case. The next one is AE action numeric is, so A action none 2, when A action is interrupted, none is 2, action is interrupted. So 1 will be the none, 2 will be the interrupted, and 3 will be the discontinued, and 4 will be the not applicable, and 5 will be the unknown. Okay, so I'll keeping this the same thing here. So if none, you give us 1, interrupted give us 2, discontinuous 3, drug withdrawn 3. So will be the discontinued, and drug withdrawn will be the 2, 3. So discontinued, so it does not give anything, but drug withdrawn will be the same. So not applicable giving as a 4, and unknown is 5, those not changes will be the 6. So the lambda functions in the numeric format here, and the AE action, and apply lambda get x, and the remaining is missing, and apply in the PD series. So when I click on this one, and if I refresh the data, so when I check here, you see here total 12 counts will be the those not changed, and the 5 counts will be the 0, like um, none, and the 9 counts will be the 9 counts will be the those not, maybe not applicable something. So the those not change will be the highest. You see the 46% are present. Okay, let me continue with the next one here. So this is the parse date. So I'm creating the function called parse date. So basically what does it do? It takes a date and time string, possibly in ISO 86601 format. So split into the date part and time parts, default as a 001 if missing, and parse the date part into Python datetime project. object, sorry. If the string is yyymmdd, yyymmdd, it returns the exact date. And if the string is yymm, it assumes the first of the month. If the string is just yyy, assume January 1st. Okay, assume January. So it is giving the, it is a function what's like a imputation in the partial date. Okay, so if passing fails, it returns to the none. If it is failed, it returns to the none. Okay, so the next what we think, we doing the estimate the date time. So here the converts the new date column into the pandas date time in just in case. Okay, then we have what we doing, we calculating the study days, computes the number of days treatment started, treatment start date to AE start or end date. Okay, adds one, so that the first day is day 1 or day 0. Okay, then we are doing the treatment emergent flag here. Flags AE treatment emergent, TRT EMFL equal to Y if they are already flag AE term equal to Y, or if the start date is on or after the treatment start date, on or before reference period, otherwise leave as a blank. So this is the treatment emergency. So basically this is functioning as creating that if there is any partial dates, we creating as completely date part. And by using the adding the 01, 01 if it is a day is missing, if a month and day is missing, we're giving as a 01 January 01. That is for the part for the partial date for the year is present. And else if there is nothing is changed, we have to give as a none. Then we have applied the same thing. A started by using this passy date here, A started and A start time. Okay, so then what I'm doing here, I'm considering only the date part of A analysis started, analysis ended. Then I'm doing the study day calculations here by just subtracting from the treatment start date and subtracting from the TRT for AE end date, and by adding the plus one, it should not be have any zero. So the treatment emergent flag is obviously because if treatment started greater than or equal to analysis start date, and analysis started is greater than or equal to reference period end date, then we give as y, else missing. Okay, if I run this part and if I go check the AE3 here, I refresh the data. So here we have analysis time and analysis end date. So analysis end date time, and you see here analysis study date, analysis end date, and treatment emergent flag. So we will be having the study day calculations, I mean study day duration, and along with the treatment emergent flag. So let me check, is there, if so I completed these two here. Okay, so I just try to filter by only this part, filter by into this one. So here I started with A start date and AESDTM. So and also start. Okay. Okay, so wait. Okay, so here what I did, I just tried to rephrase, I mean record this part, because it seems like I have some few analysis start date time and analysis start flag is missing. So now I have those information. So if I go here, for example, okay, so if I go, so analysis start date, so I'll be having that information. So since the AE start date and AE end date, there are no partial dates, that's why I cannot see any I don't see any flags are present here. So I'll got the analysis start date time and analysis end date time. So the previously these variables are missing. So now we got this information. So just what I did, I just tried to recording this part by applying that flag here. Okay, so by using this panda t series offset import month end function here, then I applied the same pattern by using the lambda x for the PD series for analysis start date, analysis time, and analysis flag, start date flag, and I'll do the same thing with the end date part. Then what I did, I just combined in case if there is a 01 is missing, like the month, the day is missing. So I apply for that end part here. Then I calculate that and I did with combined with analysis started with analysis time by separating with a small space between them. I do the same thing with the end date time, and I calculate the analysis study date, analysis end date. Then I did the treatment emergent flag. Okay, so once I run, I found I have created this like the required variables, all of them. So when I check the specification here, so we'll be having this part. So analysis started time, and analysis start date flag, and analysis ended time, and analysis ended flag. Okay, so once we completed these five variables, I'll make it this part. Okay, so here I'm just trying to make them as a green. I think it's all of them are completed along with the treatment emergent flag. Okay, so next what I'm doing here, I'm just trying to get all those required variables to this column for ADS whereas I'm creating as one global kind of variable, and then I'm applying that AE3 whatever the columns are here, and applying for these variables. We're selecting those variables call for call in ADA whereas if call in AE3 dot columns. Then I'm doing with AE4 here. So I'm creating as a new data set for the existing column. Then I'm applying for the labels. I'm selecting the labels. Okay, I'm doing the labels. I'm checking if there is and applying those labels to this columns. Okay, for AE4. Then I can see what are the change. If, I can able to check if the labels are applied correctly or not. So here, because I cannot able to get from here, that is one of the problem with the data wrangler. So I cannot able to see the label part. I can able to see only this column part. So you'll be having 53 columns, but I don't see here the label. Okay, then what I do next, I just output them. Okay, so I output them into the ADAE in the CSV format. So it will be the same pattern how we did the previous classes. So previous previous videos how I did I created the, I'm sorry, I just have to change here ADAE datasets. So AE4. So when I rerun back, so I can able to check. I'll be having the 26 rows and 53 columns. Okay, so total 26 events I have it. So when I go and check here on the Python, for example, here in the Adam datasets, I'll be having the ADAE in the CSV format. So this is the final dataset we have. Okay, all the informations are present as per the required specification. Okay, hope you like this video, and if you don't understand, please give a comment. Thank you for watching.